Hello friends, I hope you all are enjoying ease of online education. So today, in continuation to our effort towards online lectures, we will be discussing seed drying. So, without further ado, let's get started. Seed drying is the process of lowering the moisture content of the seed in order to improve the vigor and viability of the seed and thereby increasing the storage life. It helps to keep the seeds free from pest and disease incidents. Drying should be done at a lower temperature. While the seeds are drying, moisture from the seed surface gets evaporated first and the moisture from inner layers of the seed is transferred to the surface for further drying. Several methods are available for drying seeds. Some are more suitable in certain environments and safer for the viability of the seeds than others. Drying seeds in an atmosphere of reduced relative humidity is recommended. The lower the humidity, the faster the seeds will dry and the lower their final moisture content. A relative humidity of 10 to 15% and a temperature of 15 degrees Celsius are recommended by the IBPGR Advisory Committee on Seed Storage. Try to obtain these conditions as closely as possible. A number of methods can be used with safety and one should be chosen depending on the equipment available. These methods are broadly categorized into two types. These are natural drying and artificial drying. Natural drying or sun drying is the common method of drying followed in the field or threshing yard by using the radiant energy of the sun. Seeds should be spread in a thin layer to enhance the uniform drying of the seeds. Seeds with high moisture content should be shade-dried and later exposed to sun drying. Sun-dried seeds should not be kept open in the threshing yard during night times, since it absorbs moisture from the air. The main advantage of natural drying is that it is an easy and cheap method. But there are many disadvantages like slow drying, requirement of a large floor area, loss due to pest and disease attack and high weather risks. Sun drying is advisable only in the morning and evening hours. Drying in mid-noon causes damage to seed quality. There are several advantages and disadvantages of natural drying. This method is easy, not pricey, does not require any additional equipment, does not require additional expenditure on electricity and fuel. Conclusively, natural drying is a cost-effective solution to drying seeds. But this advantage comes at a cost. This is so because, in natural drying there are more chances of mechanical admixture, seed loss is more while drying due to insects, birds and animals. Natural drying takes long time for drying and results in uneven drying. Additionally, there is high weather risk and damage due to sudden rain or heavy wind while the seeds are drying in open. Artificial drying can be carried out inside the storage godown itself. Godowns should be provided with ventilators for circulation of outside dry air with the help of blowers and thereby the seeds are dried. It is possible only during the dry seasons. In some cases, drying is done by passing the heated outside air with the use of burner heater. This principle is followed in most of the present-day dryers. Main advantage of this method is that drying is uniform and done within a short span of time. But the cost of the equipment and fuel requirement is very expensive. Mechanical drying, or artificial drying can be carried out using three basic means. These are A. Natural air drying, B. Drying with supplemental heat, and C. Heated air drying. In natural air drying, natural air is blown upon the seeds using suitable air blower for drying. Continuous drying is possible in this method. In modern seed godowns provisions are made to forcible circulation of air with the help of electric blower or fan. If the outer air is comparatively dry, this method is followed. So it is possible only during dry months, as the name suggests. Drying with supplemental heat includes both air and heat to dry the seeds. Small quantity of heat is applied to raise the air temperature to 10 to 20 degrees Fahrenheit for reducing the relative humidity of air used for drying. In this method drying is performed quickly due to use of dry air, but continuous drying for a long period affects seed quality. For drying seeds using method of heated air drying, the air is heated considerably as much as by 100 degrees Fahrenheit and used for drying the seeds. This method is very time efficient, as the seeds get dried very quickly. As a precaution, the seeds should not be continuously dried as it causes damage to seed. Artificial drying also has its own advantages and disadvantages. Artificial drying is advantageous because it is a very quick method. Perfect drying is possible even under unfavorable weather condition. Seed loss is minimized when artificial drying is used. Artificial drying is disadvantageous because it requires specialized equipment and machine, which is costly. Care should be taken while drying the seed using hot air, as it causes damage to the seed. Tempering is to be followed while drying the seed in this method. Seeds which are dry will retain their viability for longer periods of storage in gene banks. It is recommended that, in general, seeds should be dried to between 3 to 7% moisture content for long-term storage, except in certain cases where it has been shown that low moisture content causes problems. For example, soybean should be dried to about 8% moisture content. Drying has an independent effect from temperature on viability during storage, and adequate drying could prolong viability for reasonably long periods without cold storage. The drying process should begin as soon as possible after the receipt of the seeds to avoid unnecessary deterioration. It can take up to several weeks to lower the moisture content to the low levels required for good storage. If there is no previous experience of drying seeds of a particular species, it may be necessary for you to do some experimental work to predict the approximate drying period. Seeds dry at an exponential rate until the equilibrium moisture content is reached. The rate of drying of different seed lots of the same species is fairly constant for seeds dried under the same environmental conditions. The length of the drying period can be predicted by using one of the two ways. These are, 1. Prediction of the correct drying period by weight loss, and 2. Prediction of drying period from mean drying curves. For prediction of the correct drying period by weight loss method, we have to predict the current percentage moisture content, and the percentage moisture content of seed required for storage. Weigh the seed sample thereafter, and use these three values to calculate the weight of seeds at the required moisture content by using the formula shown on screen. Remember to weigh the seed sample at regular intervals during the drying period until the weight of the seeds has reached this calculated value. The prediction of the drying period will be more accurate if the initial moisture content is determined. However, this is a waste of seeds when moisture content can be adequately predicted. For prediction of drying period from mean drying curves method, we need equilibrium moisture content of the seed lot under concern. Do not waste valuable seeds for this, but use either excess seeds or those which are being discarded because they have lost viability. To continue with the prediction of drying period from mean drying curves, take at least 2 lots of seeds of the species in place to dry, using the method that you will use in practice. Remove a sample of seeds and do an accurate determination of moisture content for each seed lot as per equilibrium moisture content of the seed lot under concern. For further information on determining equilibrium moisture content of the seed lot, a book, The Design of Seed Storage Facilities for Genetic Conservation by Cromartie, Ellis and Roberts can be considered. The mean of the two tests can be used as a guide because other seed lots of the same species should dry at a similar rate. Repeat the determination daily and plot a graph of the drying curve that is mean percentage moisture content against time for that species under these drying conditions. The curve thus obtained should look like the one shown on screen. The work can be repeated with seeds of all species which are of interest and their drying curves plotted for different conditions. If the seeds are very small and are dried quickly, the moisture content can be determined more frequently during the drying period to plot a more accurate graph. Friends, this was an introductory lecture on seed drying. but there is still lots more to come on subject. Please subscribe and for notifications to get regular updates. I'll try to keep lectures short and very simple to understand. Thanks for joining me. Stay safe, study online.